Well, thank you all for coming. This is our second Compass Mining Technical Meetup. Who's is their first time at this one? Cool, quite a few people. So my name's Zach, I'm chairman of the board of the Space here. The Space is a nonprofit Bitcoin education hub and social hub. So this is the education part. Pretty much every Thursday from here on out, you will be able to come in this room and learn something about Bitcoin. So this is our monthly mining focused series. Last month, we dove deep into the world of air filters. Honestly, it was pretty cool. This month, we're talking about ASIC firmware and the differences. I think that's what we're talking about, right? Okay. And so quick about the space. Again, we're a member-based nonprofit hub. So most of us here are members. It's open to the public. We have these events. If you're not a member and want to become one, we have social and co-working tiers. This room is going to be hosting beginner, intermediate, and advanced workshops starting next month. And we'll have social events. We have actually a luncheon tomorrow for members that we're going to be hosting. Mark's been leading the chef. We finally got it.
You followed through on that.
Hey, well, that's why it's a team. And this whole place has been team since day one. We've got a 9-person board of directors, and it's amazing what we can accomplish when Bitcoiners work together. It's almost like we can take on the government's control over money or something like that. Let's see. We have 73 members, and we have 4 founding sponsors, Casa, Compass, who is hosting tonight, Unchained, and Fetty. If you have any questions or want to learn about any of those companies, we're happy to teach you. Let's see, what else tonight? We're talking about firmware. Eli and Neil will be diving deep into the world of Bitcoin ASIC firmware, mainly the stock firmware versus aftermarket, and why you may want to consider one or the other. It's actually I think it's going to be a pretty awesome topic, and we're recording it. So if you didn't get it all right away, we'll be having it online for a follow-up. If you want to support the space, you can support us at donate.denver.space or by joining as a member. I think that's it. We'll welcome our speakers tonight. Ryan is our moderator tonight. We need a moderator.
Awesome.
Thanks, Zach. So you covered a lot of what I was going to say, so it'll be quick here. We're going to be focusing on firmware. Just kind of the groundwork that Curtis started last month. We're going to highlight, or we'll do the agenda. We've got a couple mining jobs that we're going to put a spotlight on, and then we'll go into stock firmware, custom firmware, and then we are going to have a Q&A session at the end. So if possible, please save any questions you might have until the end. With that, we'll start with the first job. We had this one last month, but it's still available. It's with Syntech, it's Strategic Project Coordinator. Syntech is an awesome company, so if you're interested in that role, please look them up. And then we've also got one for a site lead with Compass. We've got a new site in Iowa, so if you or anyone in your network is interested in something, a role like that, please make sure and look up Compass and reach out to us and apply. With that, I'm going to allow our 2 speakers to do some brief self-introductions. Neil?
Awesome. Neil Galloway. I've been in the space for quite a while, formerly with Compass Mining as Director of Mining Operations and as Director of Technical Sales for Foundry. I've pretty much built out a lot of operations hubs for different companies. Been around the space for a while. Eli?
I'm Eli Hendrickson with Compass Mining. I was the very first service center employee when we built that in Oklahoma City, and then we transplanted that here to Denver. I've done a lot in the field, facility operations, research and development, data science, repaired many different kinds of like miners at the hashboard level, or whether it's the entire machine. So.
Nice, excellent.
Yeah.
So I think we're going to get started with kind of see the log from the startup of
Yeah.
stock firmware. So Eli is going to walk us through that process. So this is the beginning of that log.
Yeah, I got to get up and see this. So like, whenever
not
we're
cutting
talking
all
about
these
the topic of like what we mean by stock firmware or official firmware versus custom firmware, I think it's important to have sort of a frame of reference to understand what it is that we're trying to exploit and change here. So we have a breakdown here of an S19J Pro. It's a BHB 42601, the first generation of S19J Pro hash board. So it's a pretty standard log in terms of like what it is that the firmware does with the machine, how the handshakes work, and so on and so forth. So the initialization phase, the chain number 3, for example, indicates that there's 3 chains of machines. So you have chain 0, 1, and 2. So those are your hash boards 1, 2, and 3, right? So this is just sort of like, you know, it gets the I2C communication bus going. You can scroll down a little bit. And then you see where we have power open version 0x71. So that means the machine recognizes that it has an APW 121215A power supply on it. So it goes through all of these checks, like to make, part of it is fail-safe. So it's making sure that like the hardware that in this configuration is safe to operate with the amount of power that's going to be given by the firmware, right? Yeah, exactly. So go ahead and scroll down to the next level, thread. So, you know, fixed working voltage at 1360, that means that the firmware is saying that it wants from the power supply 13.6 volts of electricity. When it says fixed frequency is 505, that's what it's going to work up to. So each of the ASIC chips, there's 126 on this board. It's going to operate at a clock frequency of 505 megahertz, right? So you can keep going down.
Quick note on that. On the logs, the reason why you'll see 1360 is because the decimal point actually messes up the code, because that would be like an integer that would tell the code to do something else. So they read everything out in 4 digits, and you can always know what that second digit is as far as like if it's 1200, it's 12 volts.
Yeah, absolutely. And let's see, so, you know, it detects that there's a PCB and a BOM version. Now what it's doing here is there's an EEPROM on the hash board, and there's 3 hash boards per machine. The EEPROM is an electronically erasable, programmable, read-only memory. And so what it does is it contains a set of instructions for everything from like voltage tables to the hash board serial number. And the firmware is programmed in such a way that it makes a call to the EEPROM and it expects a return value. And so it goes and says, what kind of hash board do I have? And then it feeds back an answer. And the firmware says, okay, well, out of all the different versions, like the most updated JPro firmware accepts like BHB 42601 and BHB 42631, probably some others. But it makes sure that the EEPROM has a hash board that the firmware is able to run. So there's some handshakes that go back and forth on this.
There's also a security aspect to that as well,
Yeah.
which the manufacturer would not like you to understand what these things mean, that way that you can't do your own things with them as well. And just to kind of like dial things back for people that might not be keeping up, there's a few EEPROMs on the miner. You'll have an EEPROM on the control board. You'll actually have a couple EEPROMs that are actually on the hash board themselves. So what's happening is usually the control board is writing to the EEPROM on the hash board, and that's telling the chips what to do. So this is where they're getting their commands from. Whenever we talk about the EEPROM, that's kind of like the brains of the operation.
Absolutely. See, we can scroll down some more. So the PIC here that it's talking about, it's a peripheral interface controller. They don't really use them so much in the newer hash boards, but what it is there's 4 temperature sensors on the board. Those are part of the fail-safes that are built in that prevent it from melting down, right? So this part communicates with the temp sensors, it passes the fail-safe, and then it allows it to continue. So it does all of these in order because if any one of these steps fail, it gets the wrong answer or something's not there, it's just going to terminate everything and it shut the machine down.
Yeah, and food for thought, like if you ever want to look up PIC kit, all one word, PIC kit, that's what we're talking about. It has 5 prongs, I believe, is it 5?
Yeah.
It has 5 prongs on it that's going to lay inside some small circles that's on that board. And what it does is that allows you to communicate with the board. You're able to push software to the board, pull the software on chip off of the board so that you can read it. A lot of times you don't get so lucky to be able to have unencrypted information on it. A lot of this information is encrypted, so even if you can pull it off the board, there's another step to cracking the encryption to understand what's on that code as well. This is all by design, of course, but we have some very smart people in the Bitcoin industry that all they do for fun is try to crack things like this. So it's pretty interesting to come from an industry where all we do is brute force cracking and then have somebody try to secure the machine that the brute force crackers are using, right? So that's always fun.
Absolutely. So yeah, go ahead and scroll down some more. Let's keep going. So yeah, and this is where the point where there's the voltage tables that we had in the table earlier we were talking about. So it gives a range, like the APW 1215 or 12-12-15, it's variable between 12 and 15 volts. So 15 is the absolute max, 12 is the bottom of it, and it will set these by steps as it goes based on tables that are laid out in the EEPROM. So the firmware makes these calls and says, okay, with this power supply version, what are the steps that we're going to set these voltages to? And then after all that's done, it's going to look for your ASICs. So the way they work is it's an all or nothing sort of scenario. Either all 126 chips on the board are found, or it can't find any. So in this case, on chain 0, which is board 1, chain 1, board 2, and chain 2, board 3, it found all 126 ASICs. So it's going to continue the log. It's going to go ahead and set frequencies for each one. So go ahead.
Yeah, and a quick note about bin numbers as well. Like also something that you'll find in this information is bin numbers. You can see 126 ASICs here. The reason why it's looking for those bin numbers is to make sure that you're not putting an incompatible board in the machine with it. So if you want to run a control board with firmware on it that believes your machine is an S19 XP 141 terahash, then the hash board needs to say that that's what it is before it will allow it to hash on that board. So not all have 126 chips. One of the unique things that the developers of some of this firmware would do is they identify the board by the number of chips on the board whenever you can't read what the encrypted information is on the EEPROM, for example.
Absolutely. So I'll go ahead and scroll down. You can keep going. It's not super important, it's just clock stuff. So yeah, this is a point where it says that it wants a minimum maximum 505 megahertz per board. So all the checks have passed, temperature sensors are there, fans are detected, power supply is compatible, and it tests it and it says, okay, can it output a max of 15 volts, yes or no? Okay, power supply version and all that's good. So once we get to this point, it says everything is set to go to set all of the ASIC chips on this board to a frequency of 505 megahertz. So, and yeah, it does that by steps. So let's see, we can keep going. None of this is really super relevant. Yeah, keep going. So, okay, so yeah, right there, that's the end of it. So basically it says, all right, so everything's passed. The frequencies have successfully been set from like 0 to 505 megahertz per board. Temperature sensors are going, fans are going. That's when in your user interface, you'll begin to see like your hash rate goes up. It'll go from like 12 to 33 to 66, 72, so on and so forth until it hits whether it's 104 terahash or 100 terahash or whatever the nominal like faceplate value is for that miner. So, at the end.
It's just Tatum for the camera.
So yeah, I think, yeah, that kind of lays the foundation for what we're about to talk about. Is this is what the brain of the miner does ordinarily from the factory, and then, yeah, what we're trying to manipulate out of that data.
So did that take like 3 or 4 minutes
It,
to start up?
Yeah, about 5.
The whole process, yeah. So this is actually a pretty big issue on the energy side. So without getting too deep off into like Texas and different grids and things like that, we have a lot of curtailments that are called for across the country, different types of curtailments and things like that. So whenever you shut down these miners, if you need them to come back on quickly, a lot of times that doesn't happen. That's actually a great segue into going from stock to aftermarket firmware. It's mainly the biggest problem that we see with it is the stock firmware is built to protect the machine at all cost because they don't want to have to deal with warranty issues, rightfully so. Any manufacturer doesn't want to have to deal with warranty issues due to abuse and misuse of their product. But with a lot of these machines, once they are out of warranty, or if you're not even worried about voiding a warranty, I'm a big believer in right to repair. That's kind of what we're talking about here, is the right to be able to change your firmware and do whatever you want to your own machine that you paid for. So a lot of times whenever you get into curtailments, there's a 5-minute clearing time or a 15-minute clearing time, depending on which grid that you're operating in. Certain programs that you can participate in, as far as ancillaries go, stock firmware just won't cut it. You can't turn the machine off and turn it back on fast enough. You can't get it to stay in a certain mode before you make it hash again. So this is why aftermarket firmware exists, is so that we can do these custom things. We'll talk a lot about Bitmain tonight, mainly because that's 80-90% of the market or so that's out there. So whenever we talk about this, just keep in mind that there is some unique traits to Avalons or What's miners, things like that as well.
I think that's a great point, because the drawbacks, like the features and benefits for stock firmware probably still apply for every miner brand. But as far as any of the drawbacks that come from custom or stock firmware, they probably will change based on the brand and the situation. So,
but it takes about 90 seconds at a minimum, at a very minimum. And a lot of times you'll see weird things happen in the firmware. Some new firmware will speed that time up, some won't. It says 30 seconds, but a lot of you probably realize, it's computer time. It's really intervals that we're talking about, not necessarily seconds at the same time.
Yeah.
So let's first focus more so on the benefits and features of staying with the stock firmware that comes on the machines.
Yeah, so there's definitely some benefits to just leaving it the way it is. You get some out-of-the-box functionality. You pull this thing out, you plug it into power, you hook it up to your internet, you find the IP, and then all you have to do is put in your pool information, and that log starts kicking off. It begins to do its thing. Warranty friendly. As long as it's on stock firmware, the warranty will be honored. And compatibility with industry standard tools is a big thing too. I've worked with some in the past that use BTC tools, a very common targeted port scanner, because whenever you're going to log into a miner's user interface, you need to know the IP address, just like a printer or anything else on your LAN. So oftentimes you'll find a situation where a targeted port scanner will not pick up the machine that you have on the network, and you have to get a regular one to go through all 255 IPs on this subnet to figure out where it is. Kind of a big hassle, and that doesn't scale. That may work for you at home, fine, but when you have hundreds of these in a container, it's not gonna work.
And then whenever we say compatibility with tools, it's a little bit of a grain of salt type of thing, because previously, I don't think there's been a new version of BTC tool in years. Whenever they were updating BTC tool, I remember very vividly holding on to 1.3.2 or something like that, specifically because it would pick up What's miners, or it would pick up Avalon miners, right? And then later on, as they would update the app, they would program it to only pick up Bitmain. This started to become a problem, and then sure enough, the old version got called for viruses or something, because it was an unsigned software, right? So we run into all kinds of little issues that we have to kind of work around. A lot of times whenever we talk about BTC tool, I think they just rebranded recently as well to Cloverpool.
Yeah, they did.
There's a lot of fake malicious software out there branded as BTC tool. So, I just say that as a warning to people. Make sure that you're not downloading anything that you don't know where it comes from. BTC.com will port you to Cloverpool now, but Cloverpool is the right place to go and download that from.
Yeah, and that's just at a micro scale. Whenever you look at the macro scale, you may have issues with Foreman or your asset management tool, where some of them don't show up, or some of them don't respond to certain commands. And there becomes situations where you may have to troubleshoot something that people aren't used to dealing with. And oftentimes in this industry, if you have a problem, there's really nobody to ask. I mean, you might get some ideas, but if you don't work the solution out yourself and publish it, it's not going to exist.
Yeah, somebody has to program that template every time. It never fails. No matter what software you use, if it's a brand new machine that lands, there's a good chance that you might have to contact somebody, reach out to them and let them know, hey, this isn't picking up. And it's not because of anything wrong with the miner management system. It's 100% because Bitmain or WhatsMiner has changed something in their firmware, and it's not picking up anymore. So this is a really, really common thing.
Yeah, another aspect of stock firmware that might be easier to manage at scale is the fact that whatever the out-of-the-box voltage and amperage is, it's going to vary by plus or minus 5%. So the math is really easy to do if you haven't changed any variables. But as soon as you go through and you start tuning your fans differently or whatever, you change your frequencies, maybe in one container but another, your load balancing can get thrown off by this. You don't necessarily know what you're spending for power anymore unless you do the study. You can get complicated fast.
Yeah, yeah. And I would say that all these variables that we're talking about, if you're a retail miner, you have 5, 10 machines, something like that, hosted with a Compass or something like that, keep in mind, running aftermarket firmware isn't always something that's easy to do in a hosting environment because it changes the variables, it changes all the metrics that we're talking about. So whenever you sign a 1-year or 2-year hosting agreement, it's set on a certain wattage, you know, and that wattage is efficient. So even if you do change out and put overclocking firmware on there, then in that situation, you're actually using more power than what you're being billed for, and vice versa. If you're underclocking, you're using less power than you're being billed for. So whenever you have like a static rate on a hosting contract, a lot of times you have to deal with stock firmware. You're not going to be able to upgrade your firmware in those situations. Whenever you're home mining, if you're mining at scaled or you're on metered power, then in those situations, 9 times out of 10, you will be billed at a metered rate on your overclock or your underclock. But then there's also going to be something that's in your MSA that says that you can't go under this certain amount of wattage. So whenever we talk about variables, the stock firmware really takes a lot of those variables out of it whenever you're trying to host machines.
Oh, absolutely. One of my biggest pain points being an actual ASIC technician in the field is the lack of clear diagnostics either when it comes to every brand of custom firmware. Some may be better than others, but all of them are pass-fail when it comes to hashboard performance, right? So the log we went through earlier was very granular and very clear in terms of what systems are interdependent and what's functioning. And whenever you see the errors, it's obvious what is not communicating with what and where the log is terminating and for what reason. When it comes to custom firmware, all of them are built off of like a CG miner-like architecture. So CG miner is sort of what they build all the stock firmware for WhatsMiner and Antminer off of, probably Avalon too. But whenever we get into custom firmware, it's different. So the logs that you get out for diagnostics aren't very good. It tells you the hashboard is passed or failed, maybe. But it doesn't tell you if it's got a temperature problem. It doesn't tell you if the ASICs have failed. So it gives you no starting point for actually diagnosing the machine.
Yeah, and also with diagnostics in general, with stock firmware, we mentioned the PIC earlier. Some hashboards have a PIC and some don't. My understanding is that the diagnostics on the ones without PIC is incredibly harder than the ones with the PIC. So another reason behind that is they changed the firmware versions. You may have one firmware version on one machine that allows a hashboard to go down and mine with the other 2 hashboards, but then you upgrade it to a new version, and if that one hashboard goes down, the whole machine shuts down, right? So I think the indicator on what we found on a lot of the op sites I was on was the ones without PIC were the ones that we had the most trouble with, that we couldn't diagnose properly.
Oh yeah, because if chain 0 is the one that goes down, I mean, you're in good shape because it'll tell you, oh, this one's failed.
Yeah.
But you know, that's the first board that it checks. But if it's like the 3rd board, chain 2, like it just won't run at all. It doesn't really tell you so much of what's going on. So yeah, when it comes to starting about how to fix the problems with it, custom firmware is not really it.
Yeah.
All right, let's move on to some of the drawbacks of sticking with the stock firmware.
Yeah, PSU compatibility. Oh my goodness, that's a big one.
It's a nightmare.
The way, in December of 2022, before that it used to be that whatever PSU shipped with the machine, that's what it had to have. So there's versions A, B, C, D, E, F of the APW 12, 12, 15 that the S19 series runs on. So the way they say it now is that DEF is a switching power supply that should be compatible with all of the machines that accept ABC, and that all the ABCs should be compatible with each other. That is absolutely not the case. Like, the more you put this into practice, the more you realize for some reason you just cannot get this machine to work with any power supply you've got. And stock firmware is really, really bad about that. And you have to know exactly which firmware version to use for it a lot of times too, for the particular submodel. So.
Yeah, and just to point out too, we're talking about, whenever we say firmware, we're talking about firmware on a control board. There's also firmware on the EEPROM on the power supply itself. This is why you get incompatibility issues, because this firmware doesn't recognize the firmware on the part that it's trying to run.
Yeah, in all reality, any PSU with the right firmware like that, rated that way, will run fine. I mean, unless it's a switching one backwards. I mean, there's certain models won't work, but, you know, barring physical limitations, like, it should work fine. And like, we've had nothing but problems with this for about 2.5 years now.
Yeah,
So.
yeah. Physically, there's nothing wrong with them. It's
No.
usually a code issue.
And that brings us to like the lack of available SD card firmware. So whenever you're going to load stock firmware onto a board for a particular model, you have to have the SD file that's made for that control board. And recently, Bitmain pulled all of those firmware files off of their website. So if your control board were to go down or something, you're completely out of luck in terms of like getting a new control board and actually making it talk to this machine. Like, you can upgrade, there's two different kinds of firmware. There's the SD firmware, and there's ones you can upgrade to the user interface. But if the SD foundation's not there, there's no upgrades that you can do.
I'd say there's 3 kinds, because you also have image files.
Yeah.
So there's a couple different ways on firmware. One is copy and paste. So you'll take your file and you'll copy and paste the files over to your SD card. The other one is actually to make a bootable SD card. Some don't take the SD card, which brings in OTP cables as an adapter. Those are also image files that you use on anything with the micro USB on the front of it. I think a lot of this is around like software security, you know, trying to make sure that their code is safe, things like that. But in the meantime, what they did, and I guess just to back up, you know, everything we use is experimental. Every machine that comes off the line is experimental. There's no multiple iterations of a model that we get. Everything is just kind of take what you get. So we do have to deal with what we get whenever it's all said and done. But removing those SD card files was like a really big hit to the industry just in general. Those SD card files were the fail-safe. That's the difference between your technician being able to fix it on site and having to pack it up and ship it across the country for repair to a OEM warranty center, and who knows how long it's going to be there. If they have a big backlog, you may be in there for months, and every day that it sits there, that's another day off the warranty. So I'm not saying it's by design, but it is something that really hurts us whenever we're trying to repair these machines.
Yeah. Another drawback are like critical errors. If you're an at-home miner, there may be instances where you may decide, I wouldn't recommend it necessarily, but you may decide that you want to operate a miner with 1 or 2 fans versus 4, because the firmware the same way, if it's missing 1 fan or if it's underperforming or whatever, it's going to fail out the machine to keep it from getting hot enough to do damage to itself. So with custom firmwares, you are able to modify some of those fail safes to sort of suit your risk tolerance. Another big thing is the quality of the firmware itself that comes out. So every time Bitmain publishes a new firmware, like the first one that comes out usually doesn't work that great. And then they build another iteration. And so it'll be such and such date that they put on Bitmain's website. They remove the old file and they replace it. And oftentimes the newer firmware is not better. Like for example, the S19 XP, what I believe the most optimal firmware to be for would be the November 18th, 2022 release. They're all kind of broken, they all have problems, but there are way fewer critical errors with that 2022 firmware than the newest one. But if you're going by the website's recommendations and the only file that you can get, the 2024 firmware, you may have a machine that you can't get running for anything because it's failing out something critical that it shouldn't. So you have to have a really in-depth knowledge of which release you need for what kind of machine you're running in order to kind of minimize your problems. And that gets heavy, really heavy.
Yeah, and I'd say the same thing with like models that aren't as prevalent are even harder to deal with. I'm actually reminded while we're talking about this, the T21 firmware, whenever it first came out, it seemed like any other firmware, completely normal. Then we found out that, we upgraded, half a fleet or so. And then once you upgrade this half, and this is on the old firmware, we realized that the new firmware had put some new security features in it that would not allow you to put aftermarket firmware on these machines anymore. So then you turn into all this manpower that's spent doing this side of it, and there's a decision that's made by a client that says, I want to use this firmware because of energy strategy or whatever reasons it might be. Then we have to figure out, okay, how do we get the stock firmware off of this machine, roll back to the firmware that we had, and then we can upgrade to the aftermarket firmware. So these are the types of things that, we fight with all the time with firmware, and a lot of it's security essentials, I guess, whenever it comes down to the company's view on it.
Yeah, these manufacturers do not want you to put this custom firmware on it. 0% of it is endorsed. Most of it, you just kind of hacky ways of bypassing the bootloaders to load things onto the NAND or whatever for the control board. So they absolutely don't want you to do this. And some of their releases are extremely broken. Like if you take the CV Tech control board, the CV1835 for the S19 XP, and you were to put the 2024 XP firmware on that, there's absolutely no way to downgrade it even to regular Bitmain firmware. And there's not a newer one that's been released. So whatever that release is, if it's broken your machine, you're going to have to replace the control board. There's no getting it off of there.
Mm-hmm.
Should we move on to
Sure.
aftermarket?
Yeah, great segue.
Yeah, right. You want to open this one?
Sure. Yeah, so whenever we talk about custom firmware, a few of the features, overclocking, underclocking, disabling the fans, sensors, and nearly full customization. So there's a few caveats in those bullet points. All of them do overclocking and underclocking. Depending on what features are programmed into them, determines whether or not you can disable fans and temperature sensors. The reason why you would want to do that is mainly for immersion. Whenever we start talking about using these miners, regardless of the warranty, we'll leave that aside from this point forward. Regardless of the warranty, if you want to overclock your machines in immersion, these are the types of things that you have to do with them. And because the OEM provider doesn't offer anything like this from a Bitmain standpoint, this is why a lot of the aftermarket firmware comes out. If you go to a company like WhatsMiner or even Canaan, you can ask them and tell them hey, we're actually going to put these into immersion. They'll be able to give you a version of firmware that is made for their machine that you can overclock. And 9 times out of 10, they're going to trust you to do it. Now, I can't speak to the terms around you overclocking brand new machines, but whenever it comes down to it, what that's done is it's created a very, very shallow market for things like aftermarket firmware for Canaan and Avalon. So you're not going to see aftermarket firmware for those simply because they let the customers do what they want with their machine. Bitmain, on the other hand, they have a 1-year warranty that they're very, very concerned about. And they want to make sure that the wool's not being pulled over their eyes whenever people do put aftermarket firmware on there. One of the things that you'll do whenever you dunk a miner, and I don't want to diverge too much, but there's immersion prepped miners that are already made for this. A lot of times those come with stock firmware that you can overclock, underclock on them. But what we're really talking about is dunking older miners, which for me, that is the ethos of Bitcoin mining, right? Real Bitcoin miners are not the guys that are going out there and buying the brand new thing right off the factory line. A real Bitcoin miner is a guy that's going to go and buy something secondhand. They're going to put firmware on it, and they're going to figure out something unique, right? They're going to run this thing at a more efficient rate, or the difficulty is going to go down, and they're going to say, oh, well, maybe it's time for me to overclock these things, right? Whenever we talk about underclocking and overclocking, there are ways to make your machine a lot more efficient. Just to give a quick example, so an S19K Pro, we did a sample size of about 1,300 units, and we were able to see where the 23 joule per terahash number that comes on the OEM firmware, we could drop that by about 5 joules per terahash. So in dollars and cents terms, whenever you figure 5 cents a kilowatt hour, that makes it about $65 per year per miner. And it doesn't sound like a lot on one miner scale, but these companies are using thousands of these things at a time. So it really does add up whenever you're able to add, 5, 10, 20% efficiency to these machines. So all of that to say, there's also, I don't see it on there, but there's also undervolting. That's another thing that we do with them. So you can actually undervolt overclock, get more efficiency out of it. You'll also get into some things around the board level themselves. So some of the hash board components will not come on without 11 volts. You can actually undervolt to 10.5, but even if you did, some of the components on the hash board won't come on, right? So a lot of times what we're doing is if we drop that voltage, we're able to mine more efficiently because we're not using as much power. Depending on the circumstances that you're in, kind of depend on like how much you want to overclock. A lot of people that are in immersion can overclock 50, 60%. If you're in air cooled, maybe it's 10 or 20%. Another thing to consider is the quality of the chips that you're overclocking. If you're taxing these things too much, you're absolutely going to crack them, blow them out, things like that. So I would say that the most important thing is probably just the usefulness of being able to have that optionality of what you're doing. Underclocking is actually, I think it's really discounted a lot in our industry. Just to give another quick number example, the S9 series was the same way, and we saw quantum leaps of efficiency with those. They threw so many of them out at a 12 volt power that nobody really realized that you could get a lot more efficiency out of them. So while everybody's S17s are blowing up on them, we were literally being given S9s for the cost of shipping. As long as we would ship them, then we could have them for free. So we were able to take a lot of S9s, and those are 13.5 terahash at 1300 watts. And you can actually underclock those and run them at 9 terahash at 600 watts. So if you ran two of them together, you get 16 terahash at 1200 watts. So that's the same joules per terahash as the S17 series. So I only say these because these are lessons that people learned in very, very hard ways, right? They went out and they bought the newest thing before it came off the line. They didn't know what they were getting. And the minute that it landed, literally heat sinks were falling off. Ching, 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 like somebody's seen the jingle bells thing on Telegram every year. but like these are the things that you deal with if you're not careful. The other big thing on customization, there are a lot of firms that run custom firmware. There are a lot of firms that run custom firmware. The manufacturers actually work with these firms to run custom firmware. You won't see that on like the retail end of things. One of the things, and I do have to give a shout out to LuxOS on this, one of the things that you're seeing more recently is companies like Luxor, they came out with LuxOS and they allow you to run Python scripts inside of your own firmware. These things are a game changer for guys like us, because we're trying to figure out ways to make things more efficient, and they're giving us the tools to be able to do that kind of stuff.
Oh, absolutely. And one of the other benefits too is that depending on your strategy, and that can change based on time of year, you could set a hash rate target, like say you want to overclock the machine through whatever means necessary. A lot of firmwares offer the ability to do this through a hash rate target. So no matter what happens, no matter how hot it gets or what voltage I'm running or whatever, it's in my best interest to just stay at 125 terahash all the time, for whatever reason. Now, you may want to set a power target, and it ignores the other variables. So it says, whatever my hash rate ends up looking like, I don't care. I just want to make sure that I'm always drawing this much power. If it gets this much hotter, then it's going to turn it down, so on and so forth. That could be advantageous for certain times of year. The same thing with thermal targets. If it's the summer, you may want to make sure that no matter what, you can set a pretty high limit. Like these things are pretty happy around 70 to 75. I mean, I'd say that's pretty average, and this is in Celsius. But you could say, all right, I don't want it to go any higher than 83. No matter what that performance looks like, whether it has to adjust the voltage or the clock frequency on the chip, you set a thermal target. So that way you don't have as many machines overheating in your racks if you're doing this at scale.
And this does change according to the miners you're using, the size of the chip that's underneath the heat sink. You know, the S9 series loved to be at 90C. Like, I don't know what it was, but something about that 90C, they love that hot temperature. And I mean, those things would just, I mean, they'd rip at 90C for some reason.
Get them nice and loose.
Yeah, I guess so. I mean, there was something about it. And then the other thing too, so like, whenever we talk about thermal targets, hash rate, not all aftermarket firmware is created equally. Some firmware can read the temperature sensors, some can't. So we spoke a little bit about the EEPROMs. If the aftermarket firmware you're using is not able to decrypt the EEPROM on the hash board, they have to do some hacky things to get around that. There may be a man-in-the-middle attack where they use a piece of hardware in between the control board and the hash board, and that little piece of hardware is going to be their own EEPROM so that they can write to that EEPROM to tell the hash board what to do. So if you're not able to decrypt the EEPROM, so control board agnostic is what the slide says. Yes, it's control board agnostic from the end user's perspective, but from the developer's perspective, it is absolutely not. Every time you see a different control board, they had to do all kinds of stuff to break the encryption on each one of those different EEPROMs. So it doesn't matter if it's a BeagleBone or a BB board, as they're called, the CIV Tech, the 7007, or the Amlogic board. And I think there's one more too. But out of all of those boards, you may have firmware that only works on 2 out of 4 or these 2 out of 4. That's something that you have to consider whenever you're deploying, especially at a large scale, and especially if you have multiple different types of models that you're deploying. You may need this type of firmware and that may not work on this type of miner, so that might not be the option that you go with for that piece of your mine. I'm gonna get into the drawbacks. I think that's the next one, isn't it?
Move this along.
Quality Q&A time.
Yeah. So on the drawbacks, so yes, it voids the warranty. Like I said, big fan of right to repair though. Most of us in this space, we don't put a lot of stock in the warranty. That's the nicest way I can think to say it. Whenever you have components wear out, and whenever we're talking about components wearing out, we're mainly talking about the ASIC chips themselves. As with anything, if you heat them up and you cool them down multiple times a day, things expand, things get worn out. A big thing that happens is the thermal compound, the ability for it to dissipate heat in between the chip and the heat sink. What'll happen is that actually degrades. Even in your home PC, every 4 to 5 years, you should replace the thermal compound on your PC. It's the same thing with an ASIC chip. A lot of people just want to run these things into the ground and not think about the maintenance that needs to happen with them, because there is a large labor aspect that has to happen with that. You know, if you're overclocking your machines and you're heating them up and you're cooling them down over and over and over, what's going to happen is that's going to increase the amount of maintenance that you need to do to these machines. If you're overclocking, you definitely need to make sure that they're clean, all the heat sinks are clean, the thermal compound is fresh, and I'll even say this, and I know that everybody in this room probably has not done this at some point in their tenure. Whenever you remove a heat sink off of a hash board, you need to replace all the thermal compound. It's not a question, it's not an argument. It's the way that you smash thermal compound into that heat sink, what happens is it's making a connection point. If you have degraded thermal compound that's on there and somebody's replaced a chip and they don't replace that thermal compound, there's a pretty good chance that it's not much, but it's not meeting where that heat sink lays up against that chip, and that's what's gonna blow your stuff up. Yeah, no problem. The other big thing is dev fees, man. So I would say dev fees are probably the biggest thing that people don't think about. People are very apprehensive about a sunk cost on things in this business. Nobody wants to spend money up front to make money later, or make Bitcoin later, I should say. With dev fees, that same 1,000 unit, 1,300 unit sample size of the S19K Pros, you can buy a control board, which is a conveyance for that firmware, right? You can buy that control board. It's a sunk cost of about 90 bucks. Whenever you buy the control board, you own the control board and you don't have to pay a dev fee anymore. They also call these things like hotel fees. They're little fees that are in the back end of the aftermarket firmware that's actually siphoning off a little bit of your hash rate, right? Whenever you put it on a control board, you don't have to worry about that because you're actually buying a product with that aftermarket firmware that's on there. And that sunk cost, what we were able to show is at $90 a board, at $90,000 Bitcoin with a, I think, 5-cent kilowatt hour cost of power, we were able to show a 53-day ROI on the control board itself. And in the meantime, if you're paying 2% to your firmware provider, that difference was about $2,400 to $2,500 a month, depending on whether you're overclocking or underclocking. So I say that just to let people know there is a place for dev fees. You know, if you're wanting to try things out and figure things out for yourself, you know, it's great. Like, use it, test it out. If you don't have, you know, a big sunk cost, 1,000 miners at $90 a board, I mean, it's $90,000. It's not a small amount. There is a reason to use firmware with a dev fee on it. But my advice to anybody that is running at scale is buy the control board. You know, buy the control board, make sure that you're able to put something on there where you don't have to pay $2,500 a month to somebody for a dev fee.
Oh, absolutely. And another drawback to it is that what it's doing is it does writing back and forth to like the NAND and the control board too whenever you install this custom firmware. So the NAND, the memory on the control board is kind of laid out in these little blocks, and like the bootloader carries like every block from the file to the block it belongs in the NAND. And whenever you go tampering with that and like there's already information there that's being overwritten, you can run into issues, a lot of issues where the firmware you put on there may be permanent. There may be no way to upgrade it because it breaks the mechanism that allows you to put an SD card in and flash it back. Or it may corrupt just a portion of it. So I've seen cases where there was a custom firmware on a control board, a lot of them. I think there's like 800 in this batch. And you could reinstall stock firmware back onto it, but whatever part of the NAND contained like the pool configuration information was corrupted. So no matter what you did, flash the machine, factory reset, the pool information would be permanent on that control board. So sometimes it doesn't completely break it, it breaks just enough of it to be a major problem.
So there's a lot of people that think they got a virus whenever this happens.
Yeah.
A lot of people think they got a virus when this happens. And I will say in the S9 series, there was a serious problem with that. There was a worm that could SSH into the machine next to it if you left the root password. Luckily, a lot of that has been solved these days. You probably won't see anything like that anymore. But yeah, the corrupt file is what actually causes the pool to not go away, because it's actually the stock or the test pool that they run it on right before they tune it, clock it, and then they put it in the box, basically.
Just kind of how you were talking about control boards, I think let's move on to mechanisms. Is that good, or did you want to hit one more thing on the
No, I think it's good. So yeah, that is another good question, is like, how does any of this firmware come to live on the control board? Well, you have like the bootloader. Technically, there's like 3 of them, but there's the bootloader that carries the info to the NAND, right? And so one of the ways you can do it is there are versions of some custom firmwares that allow you to just run it off of an SD card and overlay it. So whenever you insert it, normally the bootloader would take over and it would start writing, but instead they built like some hacky pass-through into it to where all the instruction set for the firmware is being run off the SD card. And then so for whatever reason, like the machine does break down and you don't want to deal with custom firmware for diagnostics, you just take the SD card up, power it back up, and you look at the stock log. Yeah, at scale, that would be a nightmare. I can't imagine buying 500 SD cards with a straight face for a container, but I'm sure people have done it.
Yes, yeah. I've actually seen it. I think Vanish used to run like that for a little while as well. I would
be so sick of writing cards by the end of that.
Yeah.
Yeah.
Yeah, and I will say this too, what you'll run into on things like the different control boards, and like whenever you're running firmware on one control board, it may not work the same way that it works on another control board. It's just something to keep in mind. The way that the firmware recognizes the hash board, there's a number of different like workarounds that it can use. I mentioned like numbering the chips earlier. That's one way. But the tried and true method is to actually have the key to the EEPROM that's on the hash board, so that you can actually write to and read from, which is something really important that Eli touched on. A lot of these firmwares, whenever they are installed, such as the man-in-the-middle attack or trying to use its own EEPROM, or even ignoring the EEPROM. Sometimes you'll look in the logs and you'll actually see ignore EEPROM. That's what it's doing. They figured out a way to actually write direct to the chip from the control board instead of writing from the control board to the EEPROM and back. In the process of doing this, they've cut out a lot of things that they're not able to read anymore, like the temperature sensors. So if you do put aftermarket firmware on your machine, just keep in mind and try to educate yourself as much as possible as to how that firmware is going to interact with your machine. Some firmware ignores the temperature sensors to the point where it will damage the machine. If the machine gets stuck into a boot loop, it can't read that the chips are overheating, so it just keeps on resetting itself, and then it goes through that 90-second startup, and it will just keep pushing and pushing and pushing. The way that you can see this is a lot of times they'll have fan reads. Even though there's no fans on the machine in immersion, you can see the fan clock all the way up to 100. That's how I know that that chip just got hot, right? And I can see it do this and reboot itself and do it over and over and over to the point where it completely destroys the boost circuit at the top of the hash board. Once it does that, then your machine's dead. You can send it into a guy like this and he can fix it for you, but it's not going to be cheap if it's repairable at all by that point. Not all firmware is created like that. Some firmware, I believe most should be, but it's probably about 50-50 to be honest. But the way that it should handle the error is it should recognize the error and it should shut down the machine. A lot of people want to blame the machine itself or blame the power supply. Recently I did a site assessment, 2 megawatt site, unmanned, fully remote. Whenever I went there, they were complaining about the power supplies. They had bought some aftermarket power supplies. They thought that those were crap and they went back to the stock power supplies. Whenever I got there, and this is something else too, get your eyes on the site. Don't try to troubleshoot things remotely because you're only getting half the story. Whenever I got there, they swore up and down the power supplies were the problem in immersion. The first thing that I saw was the machine was correctly oriented. You know, it was like actually flipped upside down a little bit, and it had an alpha minor power supply. The cord comes out of the back of the alpha minor power supply so that you can plug it in like that. The one right next to it was oriented face up, power supply pointing at me, the OEM power supply is on the side with the fans on the power supply. If the power supply fans are at the top of the fluid, this is the hottest part of the fluid, right? It pumps from the bottom. So the coolest part's going to be down here, which is why you want your chip density at the bottom, right? So as that hot air would float up through the hash board, it would literally come right out of the hash board and right into the power supply. And the complaint was alpha minor power supplies just blow up and they don't come back to life. But whenever I put a stock power supply on there, they die and then they come back to life and they just work again. I don't know why, they just do. It's a thermal overload is what's happening, right? So in the alpha minor power supply, they don't have the same type of thermal overload, so it pushes it to the point of breaking. Whereas in the OEM power supply, whenever I say thermal overload, think of two pieces of metal that are like this, and as they get hot, they bend up and they separate, right? That's what a thermal overload is. It's disconnecting the two contacts so that it shuts the machine down and protects it, right? So as I finish my site assessment and I'm going through all this, I pull up my laptop, I break it out, exactly what I described to you. I could see the fans clock up even though there's no fans, and I could see it just push and push and push. And I went back to the guys and I told them, I was like, I hate to break it to you, but your diagnostic's wrong. There's absolutely nothing wrong with your power supplies. And the first thing he said was, we've spent so much money on power supplies. And I said, well, your problem is your firmware. And it's the fact that it's an unmanned site, nobody's watching it. You're using a specific type of firmware that ignores the temperature sensors, jumps out a few other things, safety protocols. If you had somebody on site daily, this probably wouldn't happen. But you literally left your machines in a boot loop for weeks on end, which will destroy everything on the hash board, right? So by the time it was all said and done, this is, like I said, it's a 2 megawatt site. Couple options for them. None of them were under $30,000 to fix everything that had happened, right? So I say that as a word of warning. You definitely need to know what you're doing, and you can't run overclocking firmware remotely. It's just not a good idea. You have to have somebody checking on that stuff.
Oh, absolutely.
Well, so with that, let's get to the last one. Shout out to Tatum. He has
Awesome
stepped out.
graphics.
Thank you for this image, Tatum, somewhere wherever you are. But which is the right way to go? But in an effort of having some time for Q&A, maybe 2 minutes for you, 2 minutes for you, and then we're gonna go right into QA. So,
Yeah, I think we covered a lot of it.
Yeah.
So just share what what your feelings are and how
So
you
that
should
really,
select or approach that.
what your decision should be is, you figure out how this is working, what your cost basis is, whether it's like you're doing this at a micro scale at your house or whatever, you're doing it, at ridiculous scale. And then you say, okay, is the stock firmware performing well enough for my expectations, or do I need to sort of change some things around? Or am I experiencing a problem the stock firmware just can't get over? So whenever you're deciding which one's for you, if you're mining at home, absolutely feel free to experiment, but you need to put a lot of research into what you're doing. You can blow your machine all to pieces if you just run rampant with it. So some of them don't even have resets. So you can change some numbers and there's no default to go back to. And unless you knew what those values were, you're not going to get the stock performance back out of it. So I think a lot of it comes down to research and preparation in terms of like making that jump away from stock firmware. And is understanding, can I monitor this? Can I maintain it? What do I do if it's not working right? And like developing remediation strategies for that.
I probably get like, it's interesting because like coming from a hosting standpoint, I've done a lot of managed service and a lot of hosting. I got labeled as like the anti-immersion guy for a little while, and then I was like the anti-firmware guy for a little while. And that's just like literally not the case at all. I look at firmware just like a tool bag. It's like different firmwares are they're different tools for different things, and you want to use the right tool for the right job, right? Some firmwares are going to work better in an immersion situation. Some are going to work better in an air-cooled situation. You might want to use something that pairs well together with your miner management software, right? It really depends on you, your situation. I don't like, picking a team, especially on firmware, because, it's all a little hacky whenever it's said and done, just like everything in our business, right? Oh, yeah. So I say that with a grain of salt because if you are going to deploy aftermarket firmware, the main suggestion I would give you is speak to the people that make it. These guys are very approachable. They will help you out. Some of them don't have a lot of time, don't get me wrong, but I've always had a really, really good experience reaching out to the people that make the firmware whenever I have a problem. And 9 times out of 10, it's something I did or, something I didn't think of, right? So I would say like engage people that have used the firmware before if you can't get to the makers. And just as a final note, do not download firmware from anywhere. The only way that you can put a virus on a Bitcoin miner is to do it yourself. Absolutely the only way to do it. Nobody's gonna hack into your system or do any like funky CIA stuff to put a virus on your Bitcoin miner. The only way it can happen is incompetence. And the biggest thing that you can do is download it from some random website that says, hey, I have a repository of all this firmware for you. So just stay away from that kind of stuff.
Wise words. So I guess with that, we can open up to Q&A. Did anyone have any questions?
A million questions.
So, whenever it comes to control boards, right, you were talking about the fact that certain control boards are incompatible with certain hash boards because of the hash rate and also the voltage that they run at, right?
It's actually, it's the firmware that's on the control board that makes a difference. So like some machines will come with an Amlogic, some will come with a CI VTech. You wanna, if you gotta put aftermarket firmware on it, You're not going to put it on a CI VTech and go and put that in a machine that had an Amlogic board.
So with that, right? Say like the new S, or not new, but the S19s, right? That's all I ever see, right? Or S19s. If I have one control board that is, say, just something's wrong with it, it looks bad, the part's broken on it, something's wrong, right? It's a 144 terahash control board, right? And I take another miner and I take that control board and I just put it on that same miner that the control board was broken on. Will it still run properly and run fine without me having to do any internal work to it?
Same type of control board?
Pretty much. It's
Yeah.
the same miner, same thing. It's just swapping it over.
It will. So firmware is, like I said, the control board is just a conveyance for the firmware. So worst thing that could happen is, as long as it's the same model, same control board, same terahash rating and everything, if you're taking that control board out of this machine and put it in the other one, the worst thing that can happen is you're going to get an outdated version of firmware, or maybe the version of firmware that you want, to be honest. You know, it could be shot in the dark.
Yeah, basically, as long as the control board has an SD file at some point that was made for that control board, it'll run. So like, you can't run a BeagleBone control board on S19 because they never made an SD file for it unless some custom firmware manufacturer has. So yeah, I mean, every model is going to have a list of like control board files for it.
Right.
Funny story, BeagleBone, the name came first, not the acronym. I met the guy that invented the BeagleBone. He had a beagle as a dog. They figured out the acronym later. Shout out to Gerald.
All right, so I have a question. So let's say I'm running a S19J Pro, and the terahash is at, let's say, 104. Let's say on the dashboard it says it's at 700. What do you do if you do a firmware update and you reflash it, and that says nothing's wrong with it, everything's good? What do you do?
700 megahertz?
700, let's say 70 terahash around there.
Oh, okay, gotcha.
Yeah, what do you do on that occasion? If you reflashed it, you firmware update, nothing's wrong with it. What do you do?
And it's overclocking itself? Is that what
Yeah.
it is?
You say it's underclocking.
Underclocking itself. If you're at 70 terahash on a 104, you have a dead board because it's a
Yeah.
third of the hash rate, right?
Yep, and it says nothing's wrong with it, no diagnosis, everything's good, and green light, and you do a firmware.
Yeah, so the firmware kind of comes in two pieces, the stock firmware. There's the SD firmware that kind of contains the kernel, right?
Yeah.
And then whenever you upgrade to the UE, it doesn't affect that firmware file that's loaded from the SD card. It builds on top of it as a foundation. So most of the time, whenever I see like randomly one board is putting out like 23 terahash on those, and then the rest are at 33, most of the time it's that the kernel, the actual base firmware, is corrupted. So if you upgrade to the UE, it's just going to keep giving you the same result. You have to actually reflash the kernel itself and then build back up to the latest version.
Oh, there's steps on that.
Yeah,
Okay.
because like it's going to be the very earliest firmware version for the SD card, like 2020 or so, and the newer firmware may fix that. So you have to go from the 2020 all the way back up to where you want to be.
We probably thought about like 3 or 4 of the same exact issues probably at the same time whenever you said that. The other thing that I thought of was sometimes you'll get what's called a hardware error. If you read any like Bitmain documentation, it will tell you that hardware errors are a completely normal function of mining. You will get a hardware error, and usually the machine will correct itself because it's like a frequency issue or a throughput issue from the amount of hash that's coming through. Every once in a while, though, you will get hardware errors in lieu of hash rate, right? So if you see, you'll be looking at your UI and you'll have that one hash board. If that thing is hashing at gigahash, not terahash, but like at gigahash level, and you see a lot of hardware errors that are just ticking up, what's happening is you're having errors from the chips themselves. They're not able to run throughput through the EEPROM anymore. So essentially, it's kind of like kneecapped, like the whole machine's handicapped at that point. Yeah, and honestly, I've never seen anybody fix a machine that had the hardware errors in lieu of hash rate. Those are usually toast. That's it. Yep. What you got?
First off, awesome. I love the way that you organized it and went through this. You alluded to something huge in the industry that I don't know if everybody here appreciates fully, which is that for me personally, there were a couple of months last year where like intercompatibility was just like the absolute disaster bane of my existence. And you're playing this constant like chicken or egg game with the manufacturer where they are innovating around chip design and getting you something that is better in terms of efficiency, while simultaneously trying to make sure that you don't use those 30 tools that you're already using in your mind that are helping you do all these ancillary things, removing the SD ports so that you can't actually flash firmware and things like this. So you have this weird issue where if you want to now service your mine where you have thousands or tens of thousands of machines, you have to have somebody with like a Rolodex of information in the back of their head, and you have to have an inventory that is like a Costco warehouse to actually make this thing operate. So the main question I have is, how do we resolve this? Because this is totally untenable. Like, it's untenable to order, $10 million worth of hardware, and assuming it all works, know that it's not compatible with the $20 million of inventory that you have sitting in your warehouse, and the dudes that are going to have to learn this new interface with the 7 other kinds of S19s or other, 21s or whatever kind of machine they have. What's the resolution to this? Like, how do we get out of this situation? Because it doesn't feel tenable to me.
It's not, and I see efforts on the manufacturer's part to a certain extent. Recently, I think we just saw the big announcement where they're building out a U.S. production line for Bitmain. I think that's an answer to a few other things as well. But whenever it comes down to it, it's kind of, you spoke to the cat and mouse game that you kind of have back and forth with the manufacturer, right? I think there's an aspect of they make it hard for a reason. I call it the warranty game, right? If you ship this miner, every day that miner's out of the racks is another day off the warranty, right? The only person that benefits is the manufacturer at that point. I've been told multiple times that the reason why Bitmain used to have a 180-day warranty on their machine was because that was the only warranty they could get from their power supply provider, right? So they're actually using contract manufacturers, and the contract manufacturers in China, it's done a little bit differently. They'll say that if they have a 1% failure rate, they're going to give you 1% extra off of your order to account for that, and then it's on you to figure out how to honor the warranty from that point forward. Needless to say, this is just a sunk cost for any company. There is no way to make revenue off of any type of warranty claims. It's just straight up, hits the bottom line. So, I'm not speaking to motives or anything like that, but naturally you're going to push back on warranty claims whenever you yourself can't recoup any of that money from whoever made it, right? This speaks to power supplies. This also speaks to the hash boards themselves. There's no way around it because these are coming off of a production line in like an experimental fashion, right? So no matter what we do, we're always going to have these issues. I'm looking forward to companies like Block releasing open source platforms and allowing us, especially here in the US, to try to innovate on top of the things that they're building. The MDK that Block is putting out in the space right now, they're giving mining development kit to a lot of companies in our space. The mining development kit consists of a few minor parts, and basically it's up to you to kind of say what you would like to design, right? I'm speaking like around some things, but whenever it all comes down to it, once they release this platform, I believe that it's kind of going to open up the floodgates, and then you will actually see some things being made in the US. There's actually a really good company. It's a PCB company called Austin Circuit Design out of Dallas. They are very aware of us. This is not their main industry. They have been keeping eyes on us for years, and they're just chomping at the bit, waiting at the chance for somebody to bring something to the table like a hash board, right? Yeah. So I'm sure there's a lot of people thinking about it, but I think competition drives that innovation that you're looking for whenever it's all said and done. You want to add to that?
Yeah, I agree. I mean, I think we've all tried at some point to kind of argue with the manufacturers about things that we want, firmware-wise. And I think it's an organic consequence that we have so many, like, qualified third-party firmware providers because they're not giving us these things. So I think that's sort of the industry's response to it, is like, well, if we can't do it the right way, we're just gonna have to do it this other hacky way.
Ask one more small, quick question, just to jump on that.
Please.
So when something goes wrong on my truck, I plug something into the OBD, and it scans it, and it tells me what's wrong.
Yep.
And then when something goes wrong with my wife's car, I plug the tool into the OBD,
Yep.
and it scans it and tells me what's wrong. Do we get that with the MDK and the open source?
That's the pick.
Yeah, kind of. There are like test jigs that we use, but they're limited. So like how the chip is measured is like, it works off of basic digital signals. So you have like TX, RX. There's like a sending signal, there's a return signal. So what happens, whatever the last chip on the board is, there's an RX signal. And that return signal, it passes through every single chip in like a serpentine fashion. And if it gets broken anywhere at all, you get 0 ASICs out of it. Or if you get lucky and it terminates at one point, you say it only finds 53 ASICs, you're pretty lucky because those are the easiest ones to deal with. But most of the time, the best tools we have just report 0, like it's broken. There's some boards give you some ways where you can probe around and do some things to get it to report a number. But no, the very best diagnostic tools in the industry, A, are illegal because they're made in Russia, but B, like all the best tools even, don't do a very good job of telling us what the picture is. So there's a lot of ambiguity even for those of us that are very experienced in terms of figuring out what in the world is wrong with this thing.
Yeah, I can't tell you how often I have to like kind of dial it back a few generations and go, oh, I've seen this before, you know, and the Z9, they had a turbo mode, you know, like, I mean, there's all kinds of stuff. And that's what makes it so hard, honestly, is there's no telling what's going to come out next. And like, whenever they do release something, it's very much specific to their machine, their ecosystem, you know? I would even say, like, we talk a lot about like minor management systems. A lot of minor management guys, like Dan from Foreman, could probably tell you stories for days about trying to scrape logs or read logs or pull certain terms out of a log so that he could create an error on his end, you know? I've heard that from just about anybody. Mehdi from Load, you know, same thing. Like, all of these guys, they're trying to counteract exactly the complaint that you're having by building a layer 2 in the minor management system that actually tries to diagnose it. But as with anything, they're dumb errors, and they have to have interpretation. Like, you can't, I'm thinking of like an overheating error can actually be a bad fan, right? And the fan's still spinning, so it's picking up a read, but you don't know it's a bad fan until you physically look at it and see that one's spinning slower than the other one. You know, that'll throw you for a loop because you're sitting there thinking, well, this thing's overheating. Let me take it apart and clean it out, put it back together. Oh, it's still overheating. Let me stand here for a second and stare at it, and then it hits you like a ton of bricks. I bet it's the fan. Let me look at the RPMs. Yep, it's the fan.
Yeah, at the hashboard level, really, it's more like OBD1, where you like take the paper clip and you short the 2 points, and the light flashes a certain number of times, and if you know what that means, you know where to start looking. But that'd be more what I would compare it to.
Yeah. So you're hopeful.
You're hopeful. But hope gets you only so far in this industry. You gotta be educated.
No doubt. Any other questions?
You guys kind of talked on like some of the dev pricing. Could you kind of give me more insight into aftermarket firmware pricing? Are these like big corporate contracts? What are the negotiations like? Can you like, what is it like? How do you compare, you know, players and stuff, and just give us more insight into what it's like? And, you know, if you're running like a Megamind, can you run multiple firmware? Are these like exclusive deals? Like, I'm thinking, you know, kind of like traditional corporate software, you know, it's very, you know, kind of walled garden. It's like very, you know, protective over its like their software. So what's it kind of like in the firmware world?
Yeah, so it's all over the place, to be honest. So you will have, aftermarket firmware is always going to have a dev fee on it if it's something that you can download and use freely. That's how these guys get paid. You know, I don't mean to knock the dev fee. I don't want to make it sound like that at all, because, like, you know, everybody's got to get paid for their service whenever it comes down to it. But the big thing with the way that they charge is if you're under a certain amount of miners, it you probably won't get the phone call with them, right? But like if you are at scale and you're like one of these larger companies, the 2 or even I think there's some that are like 4%. It starts to not make sense anymore. With Brains, I believe it's 2.5. Yeah, so it's 2.5% with Brains on the dev fee, but they're trying to make it a sticky situation with their pool. So if you mine with Brains firmware on Brains pool, they'll rebate that fee back to you, but you're still paying 2.5. You're just not paying 5% at that point, right? So that's one way that they do it. And of course, at a certain threshold, a certain amount of petahash, not just Brains, but other companies as well, they'll discount that amount. And then if you're talking about like at a very, very large scale, 100, 200 megawatt facilities, 9 times out of 10, you're going to see some kind of licensing agreement with the firmware makers. Now, also keep in mind, if you're that scale, you probably have the capability to write software and build your own firmware as well. So this does happen. The big thing that the big concern is, does this firmware work with the miner management software that I'm using? Just recently, I think I saw, was it Foreman hooked up with, was it LuxOS or something like that? Yeah, forgive me if I'm saying the wrong thing, but Foreman had like an easy install, like you can install directly from Foreman to the mine. These are the types of things like, that's the indicator. This obviously works with Foreman, right? There are other firmwares out there that live on control boards that don't work with Foreman to this day, and you have to run them in like compatibility mode. So not only are there workarounds for the OEM manufacturers, but like whenever you start talking about aftermarket miner management software and firmwares, there's other workarounds that are being created internally by these companies that are designing their own firmware to make it work with the miner management systems, right? So all that to say, there are a lot of different ways to charge for it. There are a lot of different models to it, but all of these things add up on the back end. You're gonna pay, I think the list price for Foreman's like 50 or 60 cents per unit per month, so that added cost on top of the firmware that you're installing, on top of the full pool fee that you're already paying, these things add up in the back end. I've actually done some audits on people's sites before, and I've seen them paying up to like 10% in fees, just off of like various deals or firmware or software, things like that. So you really got to be careful with like what you're diving into. I mean, like I said, 1,300 units was like $2,400 a month compared to a 53-day ROI on a control board, right? So be smart about what you're doing. Consult as many people as you can, because there's probably stuff out there that we haven't even heard of that's readily available, and it could be something better than anything that we've mentioned here tonight.
Well, I want to say thank you to Neil and Eli. Thank you so much. Absolutely.